Hey guys, welcome back. This is going to be a video on just a whole bunch of different problems on integrals. I'm going to remind you guys that we cannot integrate anything that's a product or a quotient, okay? We need to use the power rule for everything. When we get to products and quotients in the next video, I'll show you about the U substitution. So this is just going to be based off of some of these problems. Now, a very common question that teachers like to ask is something like, number one, what is the integral of pi to the third dx? Many students think it's pi to the fourth over 4 plus c. That is incorrect. Pi is a number. Pi is roughly 3. 3 to the third is 27. If I asked you what was the integral of 27 with respect to x, wouldn't you just say 27x plus c? Similarly, pi to the third is just a number. So the answer is actually pi to the third x plus c. So that's going to be choice D. So I hope that makes sense. Pi is a number and not a variable. Okay, number two. Well, this is very nice because these terms are all separated by pluses and minuses. So we're just going to use the power rule for integrals, which says add 1. So this is going to equal to add 1 to the exponent and divide, add 1 to the exponent and divide, add 1 to the exponent and divide, plus c. So then you go and take a look at the choice, and it looks like it's going to be choice D. In problem number 3, I have a huge problem because it's really a base to a power other than 1. So what I'm going to have to do in this case, and you probably already see it, is you're going to have to write it twice. Okay? Then you're going to distribute, so you're going to get x to the fourth minus 2x squared makes minus 4x squared, and minus 2 times a minus 2 is a positive 4. But remember that when you are simplifying or expanding, you are not integrating. So you haven't really touched the problem yet. It's very important to keep these integral signs along for the ride, okay? So I'm going to just push this up here. Now you can integrate, and you're going to get x to the fifth over 5 minus 4 thirds x squared plus 4x plus c. So it looks like it's going to be choice A. Okay? So we're going to have to write that out twice. You're not allowed to add 1 to the exponent unless it's a single term. Okay? Unless each one is like x to the fourth, x to the third, not a base that has a binomial. Next one, same story. You're going to have to multiply it out. This is number 4. So x squared times 1 is x squared. X squared times negative x is negative x to the third. 2 times 1 is 2. And then 2 times negative x is negative 2x. You should put parentheses around it with the dx, and you should actually rewrite it in order, so that way your answer will show up in order. So it's highest exponent first. Every variable has a sign in front of it. So this is going to be negative x to the fourth over 4 plus x to the third over 3 minus 2x squared over 2 plus 2x to the first plus c. This piece here cancels out. And then we're just going to look for, I think it looks like it's going to be choice A. So I hope that makes sense. You cannot integrate products or quotients. This is a product. So multiply it out. In the next problem, you can pause the video if I'm going too fast. In the next problem, it's a product. Okay, so we're going to multiply it out. X to the third times x to the third is x to the sixth, not x to the ninth. When the bases are the same, we add the exponents, okay? So you just multiply that in. and then you get x to the 7th over 7 minus 2x to the 4th over 4 plus c. You're just adding 1 and then dividing. So I'm going to go with this answer because 2 over 4 makes 1/2. Once again, you're not allowed to integrate products or quotients. So in this case here, guys, I'm going to divide each piece by x squared. Each piece. And you might say, is that legal? Yeah. The reason why it's okay is because the denominator is a monomial. That's the only reason that you can do that. So when you divide, you guys remember? Keep the base, subtract the exponent. 5 minus 2 is 3. Keep the base, subtract the exponent. Keep the base, subtract the exponent. Anything divided by itself is 1. So you're just going to add 1 and divide, add 1 and divide, add 1 and divide, and then you should probably get 3/4. So it only looks like this is the answer. Okay? So that's just basic. Just a few more that have to do with radicals, and then I'm actually going to stop this video and do the remaining problems on a different video. Okay, why can't we integrate this? Because it's a quotient. What is the square root of x the same as? X to the half. So it's just about rewriting it. Did you know that square root is x to the 1/2? But it's still a quotient. We can't integrate quotients. So how do we do this? We're going to bring up 1/2 to the top, leave the 1, and there should be a dx. And now we're going to add 1 to the, so this is number 7. We're going to add 1 to the exponent. And the way that you should add 1 really quickly is you take this -1 plus 2. That's 1 over 2. Okay, so you can add 1 to any exponent really quickly if there's a fraction by taking the numerator and the denominator and adding it. Okay, or you could just add 1. Dividing by 1/2 means multiply by 2 plus c. That's that case. The next number 8 is exactly the same. So remind yourselves that the way that you write that is x to the 2/3. Okay, the exponent inside is the numerator, the exponent outside is the denominator. So you still have to rewrite it over because you cannot integrate quotients. Okay, so I gotta erase this. Erase this. Okay, so what do we do in this case? Well, we're gonna add 1 to the exponent. What's -2 plus 3? That's our little trick. That's 1 over 3 divided by 1/3 means multiplied by 3. Okay, so divide by 1/3 means multiplied by 3. Okay, and here's our final problem for this video, I believe. No, there's actually one more. Okay, so in this case, sorry about the noise in the background, number 9, it's gonna be 3u to the -3/4, okay, you bring that up, minus 4u to the +1/2 plus 1 du. We're going to add 1 to the exponent. You get 1/4, and then we're going to divide by 1/4 means multiply by 4. Leave the -4 out. We're going to add 1 to the exponent, so 1/2 plus 1 is 3/2. Then we're going to divide. Who gives me 1 with respect to u? Please don't say 1x, 1u. Okay? So now we got 3 times 4 is 12. U to the 1/4 looks like this. Okay, numerator's inside, denominator's outside. Minus 8/3. That's going to be u to the 3/2. And then plus 1u plus c. Our answers may just be, no. Oh, I'm sorry. This says, this part here says 1/3. I apologize. Okay, so this is 1/3. So now it's going to be 4/3 And now this is going to be 3/4. Sorry about that. This is going to be 3/4. So these two are going to cancel each other out. Let's get rid of this here. So you're left with minus 3 u to the 4/3 plus 1 u. So 12 u to the 1/4 minus 3 u to the 4/3 plus u plus, of course, c. Okay? So the exponent inside is the numerator, the exponent outside is the denominator. If it's on the bottom, you bring it up as a negative. If it's on top, you just leave it as a positive. Here's our final problem. I rewrote it. You can pause the video to read it. How do we add 1? 3 plus 4 makes 7 over 4, 4 over 7. You have to divide by 7/4, which means multiply by the reciprocal. Leave the 2, negative 2 plus 3, positive 1/3, 3 over 1 plus c. 4/7 x to the 7/4 minus 6x to the 1/3 plus c. Okay? Now, sometimes, I'm okay with this answer, but sometimes the answer won't show up if the numerator is higher than the denominator. So you say, how do you write 7/4? 4/4, 3/4. 4/4 is actually just 1. So 4/7 is x to the first and then x to the 3/4. The only reason why I'm doing this is because my answers don't show up in the way that I want. So it looks like it's going to be this, but this is 4/7 x 4/4 root of x to the third root x to the first plus c. So I hope that makes sense. 7/4 is 1 and 3/4. 1 and 3/4. Okay? So come back for the next video where we work on the trig.